A new day dawns as you awaken and prepare for the day. You take a shower, put on your undies, and finally you put on your clothes, ready to face the day. Of course, there is nothing to stop you doing things differently. You could have put on your clothes, then your undies, and finally taken that refreshing morning shower. People around you might not understand why you are dripping wet with your undies on the outside, unless of course you are Superman, just returning from rescuing a damsel in distress from under a gushing waterfall. Although it is possible to prepare for your day by putting your clothes on, then your undies, and then taking a shower, by convention, we do it the other way around. Similarly, in mathematics, we have conventions to follow so that everybody has the same understanding about which calculations we do first. One such convention is the order in which we perform calculations. You may see this written as the order of operations, or the order convention. Now that you are dressed in the conventional manner, let's go shopping. First to the grocery shop. I need 3 cartons of milk and 3 loaves of bread. At the checkout, the assistant scans the things separately to total $9.30. Let's look at this calculation written out as a mathematical expression. This involves adding decimals. We have the price of each item written out individually, and then the total calculated. We have added the numbers in order from left to right. Alternatively, when there are a number of items the same, they may count the number of items and multiply by their scanned price. Let's take a closer look at what this checkout docket is telling us. We have 3 items at $1.20. and 3 items at $1.90. Notice next that the docket has given the total for milk and then the total for bread. Finally, the overall cost of the purchases is given as the total at the end. This time, the calculation has not been performed from left to right as we did before. This time, the multiplication at the start was completed, and then the multiplication at the end was completed. Only after these 2 multiplications were finished was the final addition performed. We have now discovered the first of the rules for order of calculation. We must do multiplication before addition. You may like to check this on your calculator. Scientific calculators use this convention when calculating, so you don't have to indicate the order in which you would like things calculated. Earlier, the checkout register followed the order of calculation rule that states that we should do multiplication before addition. We have still moved from left to right across the expression. The same rule applies to division. Suppose that we had bought the 3 milk and the 3 bread for 3 friends who are unable to get to the shops. If we knew that the 3 milk cost $3.60 and the 3 bread cost $5.70, how much would each of my friends pay? We would work out how much each has to pay for milk and how much for bread, and then we would add these 2 amounts together. Each of my friends would owe me $3.10. Here we have calculated the divisions before the addition at the end. In general, the order convention states that we should do multiplication and divisions as we come to them, moving from left to right across the expression. Then we should do the additions and subtractions as we come to them, moving from left to right. Let's go to the butcher, where we're going to need to use fractions. At the butcher's, we need half a kilogram of T-bone steak, costing $8.50 per kilogram, and 1 3/4 of a kilogram of mince at $6.80 per kilogram. Let's now write this out as a mathematical expression. 1/2 at $8.50 and 1 3/4 at $6.80. Now to work out the cost. Looking from left to right, we come across the first multiplication, which we must solve. Moving along the expression, we come to an addition, which we will ignore until we are sure there are no more multiplications or divisions. Continuing along the expression, we come to another multiplication, which we must solve. We are now ready to solve the second line. Looking from left to right, there's only one thing to do, the addition, which we do, and write the final answer on the next line. Calculations with fractions also follow the order of operation convention. In fact, it doesn't matter what type of number we are dealing with, positive or negative numbers, whole numbers, decimals or fractions, they all follow the same convention. The last stop on our shopping expedition is the hardware shop for some materials to finish the pergola. Here we need to get some 8mm bolts in various lengths and some shade cloth. We need to get 20 15cm long bolts at $1.50 each, 20 10cm long bolts at 90 cents each, 20 5cm long bolts at 60 cents each, and 20 meters of shade cloth at $4.50 per meter. Let's now write this out as a mathematical expression, writing the costs in dollars. 20 at $1.50 and 20 at 0.9 of a dollar, and 20 at 0.6 of a dollar, and 20 at $4.50. Now to work out the cost. We calculate by moving from left to right and evaluating any multiplications and divisions. Now move left to right again and evaluate any additions and subtractions. $150. That's a bit more than I'd hoped. Still, I've got to get this pergola finished. Just looking at that calculation again. We bought 20 of each item. What if we had added up the cost of one of each item and then multiplied the total by 20? That would have made the calculation a bit easier. But how do we write this so it is clear that we add up all the single costs first and then multiply by 20? The way to do this is to put the calculation we want done first in brackets and then the remainder of the calculation on the outside of the brackets. Evaluating the brackets first, we move from left to right and look for multiplications and divisions. As there are none of these, we now look for additions and subtractions and evaluate these from left to right. This gives us $7.50 multiplied by 20. Again, move from left to right and look for multiplications and divisions. There is only one of these, which we evaluate to get $150, the same answer that we obtained before. We could have written the 20 at the front of the brackets, but it wouldn't matter. We still do what is in the brackets first. We can also do this on the calculator as it has bracket keys. Just press the keys in order as before, inserting the bracket keys as you need to. We can now include this rule in our order convention. Do what is inside the brackets first, then do multiplications and divisions as we come to them, moving from left to right across the expression. Then do any additions and subtractions as we come to them, moving from left to right. What if we'd been given the bill for the pergola materials set out like this? How could we work out how much the shade cloth cost? We would need to multiply the 20 by $4.50. Similarly, if we needed to know the cost of 20 of the longest bolts, we would multiply 20 by $1.50. In fact, to remove the brackets entirely, we would multiply the 20 on the outside by each of the terms on the inside of the brackets. We can think of this as having distributed the 20 to each of the terms inside the brackets. This rule is called the distributive law. Sometimes it is easier to think of a calculation by putting in some brackets. Sometimes it is easier to have no brackets. Either way, it is the distributive law that will tell us how to do it.